Okay, in this lesson on segment 1-3, we're going to focus on segments, rays, and parallel lines and parallel planes. So we're going to focus on 3 learning goals for this. So you might just want to indicate that we're looking at learning goals 3, 4, and 6. So we're going to understand how to use correct naming conventions and labeling for 2-dimensional and 3-dimensional figures. We're going to identify and describe relationships of figures in 2-dimensional and 3-dimensional space. And then we're going to understand what is the relationship between these things that we call segments, lines, and rays. So let's get started. First, let's talk about some notation here. When we talk about a segment, we're talking about a part of the line. And it's the part of the line that consists of 2 endpoints and then all of the points in between them. So we really have endpoint A over here, we have endpoint B over here, and really all of the other infinitely many points that there are in between them, those are points on the segment as well. So we call this segment AB. You can see we have one endpoint, the other endpoint, but that segment is on the line, which we call line AB. The notation that we use for a segment is we name it with its 2 endpoints, A and B, and then we draw the little overbar on top. You do not need to draw dots at the end of the overbar, just a nice straight line. Okay, segment AB is exactly the same as segment BA. So even if I reverse the order of the segment or the letters, it's still the same segment. Okay? So a ray is another part of a line, and it consists of only one endpoint this time. It doesn't have 2 endpoints because it's going to go on forever in just one direction. So here we see ray AB. It's on the line AB, but it starts at A and it goes through B. So this is really important here where we have ray AB like this. This is actually tells us a lot about the particular ray. Okay, what this tells us is that this ray starts at point A and it goes through point B. So make sure that you add that into your notes as well. Okay, the very first letter that you see here in the notation, because the A comes first, that tells you that the ray starts at point A. And because the B comes second, it tells you that it goes in the direction of B. So that's really important. The other thing is that this little arrow on the top here, that arrow is always going to point to the right. We never, ever, ever draw the arrow pointing to the left, even if the ray points to the left in the diagram. Okay, so one of the things that we talked about in class and we did a little writing about is what's the difference between how things are written. So if we look at these questions, is segment AB the same as segment BA? And the answer to this would be yes. They have the same endpoints and they have all the same points in between. So segment AB is the same as segment BA. However, if we look at this next question, is ray AB the same as ray BA? The answer to this would be no. Okay, the first one starts at A. A is the endpoint, and it goes through B. So it's going in that direction. The second one, however, starts at B and goes through A. They're going in opposite directions, so they're really not at all exactly the same. And we can tell that because this first endpoint here is different. So we know that they can't be the same ray. Okay, so what about this question? How is a ray like a line? How is it different from a line? Well, one way it might be like a line is that it goes on forever. But it's different from a line in the fact that it only goes on forever in one direction, not in 2 directions. And I'm sure you can think of some other ways that a ray is similar to a line. Okay, so we also have what we call opposite rays. And opposite rays are 2 rays that are collinear, meaning that they are on the same line, and they have to have the same exact endpoint. However, they're going in opposite directions. So if we have this endpoint right here, maybe we call this endpoint A. We have 2 rays that have A as its starting point. We got the ray that's starting here and going to the right. We have the ray that's starting at A and going to the left. And together they form a nice straight line And that's what makes them opposite rays. Okay, now there's not enough information in this picture yet for me to be able to name either one of these rays, but this is what they're going to look like when you have opposite rays. So let's actually do some practice figuring out what this might look like. I want you to draw on your paper a line that has points C, D, and E on the line. So hopefully your diagram looks something like this. We have points C, D, and E all on the same line. Okay. Then let's fill in the blank here. What would be something that would be exactly the same ray? Well, CD and CE would be exactly the same ray. They both start at point C, right here, and they both extend in the same direction. The first one says start at C and go through D. The second one says start at C and go through E. Well, that's exactly in the same direction, so they're exactly the same ray. All right, what about this? Consider this. Even though CD and CE are the same ray, while DC and DE are opposite rays. Now notice again, we're starting with the same letter here, but this time they're not exactly the same ray. DC is kind of going up and to the left. DE is going down and to the right. They're going in opposite directions, but they have the same endpoint, therefore they're opposite rays. Okay, now here's another concept that can be a little bit confusing because it's some language that we might not have talked about before. So I know you guys have all heard that lines that don't intersect are parallel lines, right? But sometimes lines that don't intersect may or may not be parallel. Sometimes they aren't parallel. And that can happen if the lines are not coplanar. So let's talk about the difference between what we call parallel lines and what we call skew lines. Parallel lines do not intersect, that's true, and they are coplanar. There is a flat plane that would go between both of these lines. They lie on a flat surface. Now, one thing I want you to do when you're drawing parallel lines, always put some markings on your line like we see right here. Those markings indicate that these lines are parallel. They're little arrows that go in the same direction here, right? So include those on there, and then I know for a fact that the lines are parallel. Now right here is the notation that we use to show lines are parallel. So here we're saying line M is parallel to line K. Okay, now let's talk about skew lines. Skew lines also do not intersect, but this time they are non-coplanar. So they're not going to be going in the same direction. So if you think about this three-dimensional box, this is really helpful. So we have line AB here, which is kind of in the front on the top of the box, and then we have line EF, which is kind of in the back of the box but going up and down. So if you think about three-dimensional space, you can see how these are never going to intersect, but they're not going in the same direction either, so we call them skew lines. There's lots of different sets of skew lines in this box. Another example might be line CD and EF would also be skew lines because they would never intersect as well. Okay, so the last thing to talk about how to draw would be two planes that are parallel. And we say that planes are parallel if, of course, they never intersect. And they're going to look like they're extending out in the same direction, and it kind of looks like one is floating on top of each other. So the way that I suggest drawing these is to do two parallelograms where the top parallelogram is just a little bit above the top line of the bottom parallelogram. Also, if you shade the bottom one, that can be helpful because it makes it appear as if it's a shadow. So if we just draw these two parallelograms exactly the same, one right on top of each other, with a little bit of space in between right here, it'll appear that they're floating, and it kind of gives that illusion that they are parallel to one another. Okay, so that's it for the stuff we have to go over for segments, rays, parallel lines, and parallel planes. Make sure you take good Cornell notes, go back in, fill in some really good questions that might go over here, and complete your summary.